If you've got an independent samples t-test, things get a little more complicated. Because first, you need to look at Levene's test for equality of variances. If the probability is less than 0.05, that means the assumption has not been met, and you should use the bottom line of the output to look for your t-value, degrees of freedom, and p-value. If the probability is greater than 0.05, the assumption has been met, and you should use the top line of the output. This is essentially backwards of what you usually want, and I think that's why something about this manages to confuse people with p-values in general. In general, it's statistically significant if p is less than 0.05. That's still the case with Levene's test for the equality of variances. But if p is less than 0.05, it's statistically significant and there's a difference in the variances. Since we want to assume the variances are the same, we don't want there to be a difference. Once you've done that, you look at the t-test results just like you would have otherwise. So here's some output. The first thing we're going to look for is Levene's test for equality of variances and the p-value associated with that. This is not less than 0.05. Therefore, we're going to say that there is no statistically significant difference in the variances. That means we cannot, that means we can assume that the variances are equal, and we can use the top line, assume equal variances. And then we're going to look at the p-value for that associated with that t. In this case, we want the upper one. We're really looking at 0.102. If the first one had been less than 0.05, we would be looking at the bottom one. Now, somehow I seem to be on a roll of grabbing things that did not show any difference, so I can just conclude that my two groups do not differ from each other. If they had been significant, I would have gone up to the descriptive statistics and compared those means. When you're comparing more than two groups, you do an overall analysis of variance, and then you do follow-up tests. So the first thing to look at is the p-value associated with f. If that is less than 0.05, then you do the follow-up tests, which you do really just like you do t-tests. For each pair of means, you get a p-value, and if that p-value is less than 0.05, you can say that pair differs and look at the descriptive statistics to figure out how. If the overall f was not significant, then you don't even look at the follow-up tests. You've probably already done them because I always automatically do them with SPSS output rather than having to go back and do it again. But I ignore them completely if the overall f is not statistically significant. Okay, so that's the basic overview. Here's what it looks like with the one-way ANOVA. So I look at the sig, the p-value associated with f. If it's significant, I do the follow-up tests. If not, I conclude that there's no effect of the independent variable on the dependent variable, and I do not look at the results of the Tukey tests. When I look at the results of the Tukey tests, there will be a test for each pair of means. So I pick a pair of means, and if p is less than 0.05, that pair of means is different from each other, and I can look at the descriptive statistics to decide how they differ, which group is higher than the other. If I look at a pair of means or I look at a pair of groups with a Tukey test and the probability is greater than 0.05, then that pair of means does not differ significantly. Okay, so here's a one-way ANOVA, and the first thing I'm going to look at is this sig. This is statistically significant, so I can conclude that there is an effect of eyewitness testimony on guilt ratings, but that doesn't mean I know what that effect looks like. And just as a quick reminder, although I did not do this with T, the degrees of freedom, they're always two numbers. The first number is associated with the between groups. The second number is within groups. This is sometimes also labeled error. You never use the one labeled total. the F value. And if you're having trouble with writing any of these statements, keep in mind that what you're really doing is writing a sentence in statistics. And just like when you write a sentence in English, whatever goes in parentheses can be omitted and the sentence still should make sense. So if you cover up the 2 and 345 degrees of freedom, you have a sentence that says F equals 5.05. Then you have a comma and another brief sentence which says P less than 0.01. Because that was significant, I'm going to look at the multiple comparisons, look at the Tukey tests, and I'm going to look at the column labeled SIG. I can see here that there's a difference between people in the no eyewitness condition and the unrefuted eyewitness condition. And there's a difference between people in the discredited eyewitness condition and the unrefuted eyewitness condition. But there's no difference between the discredited and no eyewitness conditions. Now, this gives me pairs of means and tells me which are different, but to figure out how the ones that differ are different, I need to look at the actual means. So the table up above tells me there's a difference between no eyewitness and unrefuted eyewitness, and down below, the mean for no eyewitness is 4.33. Unrefuted eyewitness has a mean of 4.72. So people think that the defendant is more likely to be guilty. They see him as more guilty if the eyewitness has not been refuted than if there's no eyewitness at all. If you're doing a two-way ANOVA, there are 3 significant tests that are done. There are 3 Fs that are calculated, 3 p-values that are determined. And all of that is before you do any follow-up tests at all. So you will have a test for the main effect of A, a test for the main effect of B, and a test for the interaction. For any of those effects, whether it's a main effect or an interaction, the test, if p is less than 0.05, tells you that whatever it is significant. So there's a significant main effect or a significant interaction, whatever you're looking at. And if p is greater than 0.05, that means there's no significant main effect or no significant interaction. Now remember, there are 3 tests you're doing, and what you learn about one test has nothing to do with what you might find out about any of the other tests. Those 3 tests are completely independent of each other. Okay, so here is output from one of the two-way ANOVAs that we looked at. So the first thing I'm going to do is look at the p-values for those 3 effects: gender, method, and the interaction. So when I look at these numbers, I can tell that there is a main effect for gender because p is less than 0.05. There is a main effect for method because p is less than 0.05. There is no interaction because 0.062 is not less than 0.05.